Okay, in this situation I'm demonstrating a invert gate of binary logic. I have a light on and the switch is off. I turn the switch on, the light goes off. So it's inverted. The switch goes off, light goes on. So far so good. Next one will be a situation where we have an inverted OR function. In this case there's two switches, 1 and 2, and one light. If I turn the one switch on, or if I turn the other switch on, the light goes off. So the situation is inverted, same as before, except now we have two switches. Either one will turn the light off. Finally, for this simple demonstration of binary logic, I have an AND circuit consisting of one light and two switches. By turning switch A and switch B on, the light comes on. It can be seen that by using binary logic we can create 4 different outputs from 2 inputs. See the truth table for 2-input binary logic for further information. Anyway, I'll show it over here. Now, with both switches off, we have one on. If I turn this first one on, that gives you a second light. This gives you the third light, and that gives you the fourth light. Although this type of binary logic is very valuable and can do many things inside a computer, it still cannot do the recognition of the direction of movement like your computer mouse can. For the direction of motion recognition, your computer mouse uses a logic that responds to the consecutive activation of 2 inputs. Okay, I took the cover off, or actually I took this whole mouse apart to see what's inside, and you can see that there's a little wheel over here, and the wheel has little slots on it. And there's an infrared emitter here and infrared detectors. There's 2 detectors on this side. So when the wheel turns, the detectors detect the on and off conditions in sequence. When the wheel turns one way, the sequence is one way, and when it turns the other way, the sequence is the other way. So in other words, the function is like this inside. Now this system here does the same thing as the logic in the mouse. To demonstrate that, I have 2 switches again, and 2 lights. These lights represent the output into the computer, and these switches represent the optical devices that take the information from the wheel. So if the first sensor is on, nothing happens. If the second sensor is on, then the pulse goes into the chip on that line. Then that goes off and this comes on. So if the sequence is in this direction, in other words, the wheel turns so that this goes first, and then this, and then this, and then this. It goes like this, this, and then this goes off and this off, this on. Okay, so the logic for the mouse is like this sequence: 1 input, 2 inputs, off, off, 1 input, 2 inputs, off, off. So when the situation is reversed, one input, second input, off, off, one input, second input, off, off. That's how the mouse works inside. Now then, I call it bionic logic. It has two inputs and it has 1, 2, 3, 4, 5 outputs. And this is where the sequence comes in. That's the two-input logic. Now then, we can go further from the two-input logic. We can put three inputs into the logic system and we can get 16 outputs. Okay, here I have three switches, three inputs, A, B, C, and A, B, and C. And this is the logic here, and I have 16 light bulbs, or LEDs over here. So now the bionic logic sequence, 3 inputs, 16 outputs. A, B, C. A, B, A, C, B, A, B, C, C, A, C, B, A, B, C, A, C, B, E, A, C, B, C, A, C, A, B, C, B, A. That's all the sequences there are. So for the three different ones, there's C, B, A, B, C, B, C, A, B, A, C, and so on and so forth. So you can see that there are 16 different outputs for 3 different inputs. Okay, now the previous one didn't work out very well. I couldn't see the LEDs. So this is the bionic logic 3 input gate. Gives you off light A, B, C. Okay, A first, B second, C third. Okay, B first, A second, C second. B first, A second, C second. C first, A second, B second. Okay, A first, B second, C third. A first, C second, B third. B first, A second, C second, B first, A second, and C third. C first, B second, and A third. What else is there? C, B, A, C, A, B, B, C, A, B, A, C, A, C, B, A, B, C. C, C, B, A, B, A, C, C, A, and so forth. I think I got all of those things now. Okay.